Okay, so today we are continuing with our overview of the electromagnetic spectrum. We talked about radio waves yesterday with the long, medium, short waves, the VHF, which are the very high frequency, and the UHF, which are the ultra high frequency radio waves. And next up are microwaves. Right? And so they have wavelengths of a few centimeters. Now, let's keep in mind that the explanation of the different radiations of the EM spectrum are not given in order, right? So microwaves comes before radio waves in the spectrum,
Okay.
right? So yeah, as you can see, so we still haven't talked about X-rays, we still haven't talked about gamma rays, right? And so the explanation is not given in order. So you, right, if you want, you can arrange your notes in order, or read it in order from the text, if you prefer that, if it would make more sense. So, right, what are they used for? Microwaves are used for international telecommunications and satellite broadcast.
Yes. Okay.
And what would satellite broadcast include? Your TV channels, right? And mobile phone networks.
Yeah.
So how that happens is, right, the microwave signals are transmitted through the ionosphere. Microwave signals transmitted through ionosphere. And ionosphere is one of the layers surrounding the Earth. So you've got the ionosphere and the stratosphere and the troposphere, I think,
Yeah.
right? So those are the different layers surrounding the Earth until you don't go far enough, and then you say, oh well, I'm in space now, right? So those
Yeah.
are the various layers of atmosphere or orbit around the Earth.
Yeah.
And
Okay.
so microwave signals are transmitted through the ionosphere by dish aerials. So that's a device, right? Nothing to do with the dishes you use for eating, right? And they're amplified by the satellites. Amplified meaning their signal is boosted. And then they're sent back to a different dish aerial in another part of the world. And that is why, for example, you're in UAE and you can, sort of see channels from other countries that are not nearby, right?
Yeah.
So you need to, well, now you've got like the cable system, so you just get a wire and you plug it in. But somewhere there are some dishes or antennae or something that are receiving the microwaves coming from satellites from other countries.
Yeah.
Okay. And so microwaves are also used for, in Bluetooth, right? Which allows short range communication between different devices. And it's also used for cooking in microwave ovens. The name microwave oven means it uses microwaves. Since they can cause water molecules in the moisture in food to, vibrate and then heat up.
Yeah.
Right, so we consider, Wi-Fi or Bluetooth or these things as, something different, but they're basically using, you know the electromagnetic spectrum in a particular way, right? Just like infrared, as the text mentioned, I don't think I don't recall mentioning it yesterday, but if you have a TV or something that uses a remote and you point the remote towards your device and press a button and something happens, that's using IR, right? So,
Yeah.
right, it's using all these different radiations from the spectrum. And so Bluetooth is one application of microwaves. Then there's obviously the microwave oven. And that's why and that's because, sorry, not why, but because the microwaves can cause, you know, moisture, which is basically water. So the water molecules to vibrate very quickly and therefore heat up. Any questions about that?
No.
Okay. Then you have X-rays. Right? Perhaps the one that we are most familiar with. And these are produced when high-speed electrons are stopped by a metal target in an X-ray tube.
Okay.
And so they have a smaller wavelength than UV. So you got gamma, X, UV, then visible light, right? So again, it's not given in order. And they are to some extent absorbed by living cells, but they can penetrate other objects. So they can penetrate certain objects even if they're solid.
Penetrate meaning?
They can pass through.
Okay.
Right? They're absorbed by living cells. Right? Penetrate, pass through, or actually, reach that part, go deep. And so, right, they are captured on a photographic film. And so if you've ever had an X-ray, uh, right, you can your bones and your teeth and metal objects and stuff like that show up because the X-rays can't pass through those. So, right. X-ray films show bones or teeth or, metal objects. So if someone has like a metal implant in their body, and we're talking about like the medical use of X-rays, right?
Yeah.
And so what's happening is that the X-rays are shot or directed towards, the target. and right, they are detected on a type of photographic film.
Okay.
And basically what's happening is the bones or the teeth that you show up are where the x-rays could not pass through. So you're obviously familiar with shadows,
Yeah.
right? Shadows are formed when you sort of block the light falling on an object.
Yeah.
That's basically what the x-ray picture is, right? So the x-rays are not able to pass through your bones and reach the photographic film, and so the white outlines of your bones or whatever it is that you are seeing on the film are actually sort of x-ray shadows.
So it's like blocking the light that comes from the X-rays.
It is blocking the x-rays.
Okay.
Okay.
Yeah.
Now x-rays are also used in radiotherapy to kill cancer cells. They're also used for scanning at airports, right? And
X-rays are used for killing cancer cells.
yes, high doses of x-rays are used in what is called radiotherapy.
Oh, okay.
Now I know it says radio, but it's not radio waves. High doses of x-rays, right, to kill cancer cells. And you know what this radio is coming from?
X-ray.
No, it's coming from radiation.
Isn't that harmful?
The entire electromagnetic spectrum. Look, you need to understand one thing, right? Scientific terminologies are not the same as what we normally understand things to be. Okay, so
Yeah.
when I say radiation, if you hear the word radiation, you're like, oh, that's harmful. Radiation is basically a type of energy transfer,
Yeah.
right? Now what kind of energy transfer it is, that is what will determine whether it's harmful or not.
Oh, it's like depending on that.
Yeah, so just because I say radiation scientifically doesn't make it a bad thing, right?
It just depends where the energy is coming from.
Yeah, right. if
Okay.
i if i say nuclear, what would that make you think of?
Nuclear bomb.
Exactly. But nuclear actually has to do with the nucleus, and we've done like the atom in chemistry, right?
Yeah.
So the nucleus of the atom, which contains the protons and the neutrons, that is where the term nuclear comes from,
Yeah.
right? So if I'm talking about something that nuclear in science, that's referring to the nucleus of atoms most likely, right? Now nuclear bombs are known that way because they're actually uh, releasing energy from the nuclei of atoms of materials such as uranium, right?
Yeah.
But just the word nuclear does not automatically mean bomb.
Okay. Got it.
Okay,
Yeah.
and it is because of this misconception. It is because of this misconception that terminologies used in public need to be carefully tuned. So you've heard of the technique MRI,
Yeah.
right? MRI stands for magnetic resonance imaging.
Yeah.
What it really is a process called NMR, sort of, right? Or it's based on NMR, which is nuclear magnetic resonance. Now, if we said oh, we are using nuclear materials. You're like, oh my god, they're using nuclear materials, it's so dangerous. Like no, right?
I think it also depends on how you're using it.
Yes, but there's like sort of this general idea of things that people have developed over time,
Yeah,
right? And
yeah,
so it's easier to change the name rather than argue and explain everything every time,
yeah,
because people are not going to understand, oh, we're talking about the nucleus of the atom. People are not going to understand that,
yeah.
so might as well not go into it, right?
Okay,
So
okay.
right, when people hear of radiation, like, oh my god, radiation, like, okay, fine, yes, right, in high doses it is harmful, but
Like whatever helps you sleep at night.
huh?
Like whatever helps them sleep at night.
Oh yes,
Like,
definitely. Right, so in general, right, x-rays are used for scanning and detection. So some applications are mentioned in the book, you can go over them. Details of those are not given, so like you just read what's given and that's it. If you're interested in details, you can look them up yourself, or after we're done with the syllabus you can note them down and perhaps we can explore them together. But just keep in mind that details of any of these applications, if they're not given in the textbook, that means that they're beyond your syllabus requirement.
yeah, okay.
Okay, after x-rays we have gamma rays, which are actually the last one that we're going to talk, like the last of the spectrum. And interestingly, these were the first guys actually, which we are talking about at the end. So, right, gamma rays are the most penetrating and most dangerous in the entire spectrum, right? And obviously, when I say most, that means they're even more penetrating and more dangerous as compared to X-rays. So yes, X-rays are dangerous, but that is if you uh, are constantly exposed to them, like over and over and over and over, right? So if I go to the hospital or a clinic or a laboratory to get an X-ray, I'm only getting that done like once every, like, I don't know, once. It's not something you do just to check up on how my bones are. It's not like a blood test, right?
Yeah,
The person who's performing the X-rays, they wear protective lead, jackets to protect themselves, because they're performing multiple X-rays per day. So they're actually at risk, not you,
okay.
right? And so gamma rays are the most penetrating and dangerous or harmful. The book compares them, in their penetrating power and uh, harm with X-rays. Over here, I'm just saying generally they are the most, right? And they are used to both diagnose and treat cancer.
Yeah,
So diagnose means figuring out, oh, does this person have cancer or not, and then also treat cancer, right? Similar to how X-rays were used. Right? They're also used to kill harmful bacteria in food and surgical instruments. So kill harmful bacteria. Then they are used in medical diagnostics. Diagnostics means procedures which are performed to find something out, right? So this is coming from diagnostics, and so they give you something that emits gamma rays, and cancer cells absorb them more, and so that shows up on a, when it's detected on a screen or by some other instrument, and so they can locate, okay, fine, so right, maybe this person has cancer in this area.
Yeah.
So gamma ray photography, in this case, like let's talk about this guy. Gamma ray photography used to detect gamma ray absorption by cancer cells. So this is not the treatment part, this is the diagnosis part, right?
Yeah.
Now for the treatment, right? Again, high energy beams of gamma rays, just like cancer rays, are focused onto the area where there's cancer to kill the cancer cells, right? So that's also part of radiotherapy. So both X-rays and gamma rays are used in radiotherapy. All right, and right, engineers use gamma rays, gamma ray photography to detect cracks and flaws in metal. So that's something that's just mentioned, and that's all you need to know, right? Because in your paper they might give you like a question worth 1 or 2 marks, like what is one application of gamma rays, and if you just list that down, right? So they're not going to ask you any details of how that works, right? Unless that detail is given in the textbook, right? If the detail of the procedure of the application is given in the textbook, then they would expect you to know it. If it's not given in the textbook and they just mention, oh, it's used for this and this, and that's all they've given, and so in the exam they ask you, oh, one application, you just write down the name of the application or the procedure, and that's it, you'll get your mark.
Yeah.
Okay, to wrap up this particular chapter, dangers of, right, EM radiation. EM standing for electromagnetic.
Okay.
And so obviously, because it is radiation, as I mentioned, right, repeated exposure to high levels of any of these is harmful,
Yeah.
right? So what's wrong with microwaves? They can heat soft tissue, right? And so they can kill cells. So basically, right, the whole thing that they can cause water to vibrate and then heat up. And so if you are like a living tissue is exposed to microwaves, it will cause the water to heat up and therefore kill, damage or kill cells.
Yeah. Okay.
Then uh, right,
Uh.
there's also the talk of the hands-free mode, where basically the use of Bluetooth. So the use of
Yeah.
Bluetooth is based on microwaves. So you got your Bluetooth device plugged into your ears and your phone is lying somewhere else. So there's like microwave communication between the two. And so is that harmful or not? Right? That is under debate.
I mean, there's still no confirmation if it's harmful or not.
According to the textbook, no. And then to be very practical and real, whether or not they actually say that, what we call as facts are many times very often dictated by prophets, right? So you have this entire technological industry that is built around Bluetooth, right?
Yeah.
Nowadays, everything is happening with Bluetooth and Wi-Fi. So if a scientific report comes out saying, oh, well, it's actually very harmful,
Yeah.
the entire technological sector will come crashing down,
Exactly.
right? I'm not
Yeah.
saying that there are harmful effects and they're being hidden. I'm saying that this does happen,
Yeah.
right? Call me a conspiracy theorist. That is not my intent, but yeah, right. So that is problematic.
Yeah. Okay.
Okay, infrared radiation we know transfers thermal energy. So right, being exposed to high intensity infrared can cause burns, right? Then you've got UV, and it causes ionization, right? So when it's absorbed by the skin in high doses, it right can obviously damage the skin.
Yeah.
So right in high doses, right, it can cause skin cancer, right? If it affects the eyes, it can cause cataracts, which is a condition right of something like developing in front of your lens, and so your vision is impaired. uh, the skin color actually matters over here because dark skin is more resistant to UV. It's able to absorb more UV light than lighter skin, right? And so
So darker skins have advantages
yes, they do.
for UV.
Yes.
Didn't know skin could cause such a difference.
Well, the whole skin thing is absolutely ridiculous, right? There's a lot of social, political, and other,
And discrimination.
exactly, yeah, right. So but skin color is natural, and darker skin does have certain advantages naturally, right? So dark skin can absorb more UV, and so it reduces the amount reaching the tissues, and so it's reducing the amount reaching tissues, and so it is more resistant to UV, right?
Yes, sir.
And so right, other ways that you can help yourself against UV is wearing clothing, proper clothing, and using sunscreen.
Yeah.
And then finally, you've got X rays and gamma rays. So, what about these guys? Again, they can cause ionizations of atoms and cells, and this can cause mutations or damage the cell, which can lead to cancer. So, it's interesting that X rays and gamma rays are used to kill cancer cells, they can also cause cancer, right? And
Is it
so,
something that is that creates the cancer?
huh?
Like how? What causes the X-rays to create cancer?
I just mentioned, right? Ionization, right? So they basically cause atoms to become ions chemistry,
Yeah,
right? They cause atoms to become ions, and you do not want free ions,
yeah,
right? So if you've got ions, they're going to react with something in the cell, and
exactly.
that can at best case scenario that it will just damage the cell. Worst case scenario, it will cause some mutation.
Yeah,
So it could lead to cancer developing.
okay.
This exact same process is used to kill cancer cells because it is causing the ionization of atoms. Ionization means formation of ions,
Yeah,
right? So it's causing the formation of ions, which is dangerous for cells, and so that's the process they're using to kill cancer. So the radiotherapy thing,
yeah.
right? They are using this exact same you know process that's for healthy cells is harmful.
So if a patient already has cancer and they use like this as a, what do you call, like as a medicine, wouldn't that cause more cancer?
Because right, no, because the x-rays or the
Are gonna react opposite, right?
no, they're not going to react over this. It's not like a cartoon or something, right? They are targeted,
Okay.
so they are only targeted to that exact point where the cancer cells are, right?
Oh, okay. Okay.
Yes, right. If the cancer is spread in the body and you're having like a full body radiotherapy,
Yeah.
then yes, not only is it going to kill cancer cells, it's going to harm other body cells as well. And that's why people who are undergoing cancer therapy, they lose their hair, they become weak, their immune system is affected, right? So there are serious side effects,
Okay.
right? So yes, it's basically you are, if I use the analogy, you are taking poison.
Yeah.
The poison is supposed to kill the cancer cells, but it will affect your healthy body cells as well.
Okay.
All right, so X-ray and gamma ray machines uh, are shielded by lead the metal, right? So lead can stop these radiations from passing through X-rays and gamma rays, and this reduces exposure or unnecessary exposure. Clear? Right now the effect of lead when we
बहुत
go
पहले मैं वो स्क्रैच इधर आया तो मैंने छिलका निकाला तो वो
right, and so that brings us to the end of chapter 3.3, which is the electromagnetic spectrum. Now, I was hoping to complete chapter 3.4 as well, so that would have, you know, put a tick mark on in the entirety of topic 3, which was waves. But I don't think that will be possible, even if I try to. So I'll just leave it for our next session, which we will have after a winter break. Right. So it's not a lot. So we'll continue with sound and then move on to electricity, which is topic 4. All right.
okay.
Right. So I'll see you after winter break, inshallah.
इंशाल्लाह
Allah Hafiz.
अल्लाह हाफिज